Okay, this is Unit 7, Day 5, the last day in the unit, and today's about the remainder theorem. Okay, it's really important that you guys know that name because in your test, it'll say use the remainder theorem, so you have to know what's going on, okay? In our last class, you saw how two polynomials, when divided, resulted in another polynomial or constant in a remainder. The remainder has a remarkable property in certain types of division. We will explore this relationship in the first example. All right, in each of the following, let p of x be the polynomial in the numerator, and x of a be the binomial in the denominator. All right, so you're going to notice that it has the form p of x over x minus a. So numerator over denominator. In each case, simplify the division using the polynomial long division and then evaluate p of a. Okay? Don't forget, the denominator, this is saying x minus a. So if this is x negative a, then your a is always that opposite sign, so it's positive 2. So this one shows that it's minus 2 right there. Okay, that's minus 2, so then a is 2. So if I jump ahead to b, this one, my a is positive 7. Okay, so that's just identifying what a is there. All right, don't forget also that this is really p of x on the top. These are p of x's there. Okay, and the bottoms are x minus a's. So if that's the opposite of a, then that's why your a's switch signs there. Okay, now it did tell us to use long division. So we did this last class, so x minus 2, move this down a little bit, I'm going to run out of space. X minus 2 is going to be divided into x squared minus 8x plus 18. So you're going to say, how many times can x go into x squared, or how does x times what, multiply times what gives you x squared? Well, it's an x. X times x is x squared. X times negative 2 is negative 2x. Put it in parentheses, subtract, but that subtraction means change all your signs here. Okay? As always, x squared minus x squared is 0, but then you have negative 8 plus 2x would be negative 6x. Okay? We're going to drop down the positive 18. And then you say, how many times can x go into negative 6x? Or x times what turns it into a negative 6x? It would be minus 6. So now when I multiply, negative 6 times x would be negative 6x. Negative 6 times a negative 2 would be a positive 12. Put it in parentheses, subtract. Subtraction means change the signs. And I end up with these canceling. And you have 18 take away 12. 18 take away 12 is a remainder of a 6. Okay. So, ready? My answer. I have the answer, the quotient, x minus 6, plus 6 out of what we divided, okay, which is x minus 2. So there's my answer. All right, now, my a is 2, okay? So when a is 2, p of 2 is going to mean you just go back to the original. Now remember, p of x was just this whole top here, guys. Okay, p of x is originally just that whole top here, and you're evaluating it at 2. So it's really just 2 squared minus 8 times 2 plus 18. So p of 2 is equal to 6. You should notice something. Okay, so keep that in mind. All right, next one here. So x minus 7 is going to be divided into x squared minus 2x minus 25, doing long division again. X divides into x squared x times, so we go x times x is x squared. X times negative 7 is negative 7x. Put it in parentheses, subtract, change all your signs. So it becomes negative x squared, positive 7x. These cancel, and I'm left with 5x. Okay, I drop down the minus 25. And then you say, how many times can x go into 5x, or x times what gives you 5x? Plus 5. 5 times x, 5x. 5 times negative 7, negative 35. Put it in parentheses, subtract, change all your signs. All right, so 5x minus 5x would be 0, and you have negative 25 plus 35 would be 10. All right, so ready? My answer is x plus 5 plus a remainder of 10 out of the original divisor of x minus 7. Remember, when a is 7, p of 7 means go back to the original numerator, which is p of x, and substitute into 7 wherever you see an x. So it's 7 squared minus 2 times 7 minus 25. So my p of 7 ends up being 10. Hopefully you see a pattern right now. Okay? All right, this last one here is, remember, this is p of x. This is x minus a, so this is telling us a has to be negative 3. It's opposite of what you see down in that denominator. So now we're going to take x plus 3, and we're going to divide it into 2x squared plus 11x plus 11. Okay, so how many times can x go into 2x squared? 2x times. 2x times x, 2x squared. 2x times 3 plus 6x. Put it in parentheses, subtract, change all your signs. So I end up with just 11 minus 6x, which is 5x. Okay, drop down the 11 plus 11x. How many times can x go into 5x? 5 times. Why? Because 5 times x is 5x, and then 5 times 3 is 15. In parentheses, subtract, change all my signs. So this ends up with negative 5x, negative 15. Okay? I'm left with a negative 4 remainder. So my quotient right up here is my 2x plus 5 minus, because it's a negative remainder, 4 out of x plus 3. When I evaluate p at negative 3, be careful here. Okay? You're plugging in a negative 3 into all of this numerator over here. So it becomes 2 times negative 3 squared plus 11 times a negative 3 plus 11. So p of negative 3 is negative 4. Hopefully you guys realize something. Look at this if I go back to the first one up here. So using this whole little p of a thing, so remember a was the opposite sign of what was in your denominator, but it always resulted in your remainder. So then when we found p of 7, because our a was 7, it was the remainder. P of negative 3 was our remainder. So what should you realize? You should realize p of a is always equal to your remainder. Okay, that's not a coincidence. That will always happen. All right, so remainder theorem. Okay, so they're just saying, like, basically, remember, this is numerator p of x. This is your denominator x minus a. It's always equal to your quotient plus the remainder over that. Okay, so now it says if the ratio of p of x, it says where q of x is the linear function, then which of the following has your remainder? Okay, so now, p of a, remember, your a in this case, if you guys are up here, your a in that case, we know that a is 9. So if I find p of 9, that's my remainder. Remember, p of a equals the remainder. So p of 9, you go back to the original. You go 9 squared, the numerator there. That's your p of x. So 9 squared minus 11 times my 9 plus 22. And I know p of 9 is equal to 4. That means that's my remainder. So when this question says use the remainder theorem, we just did it. Okay, so p of a is the whole remainder theorem. Okay, so your p of a, that's your remainder theorem. Okay, so we know my answer is 4, which is choice 4. You could use your long division to prove it, but the remainder theorem just shows you p of a. All right, it says in the past, the remainder theorem was used primarily to aid in the evaluating polynomials. These days, it is primary justification for telling if a linear expression is a factor of the polynomial. All right, so, something to pay attention to. If x minus a is a factor of p of x, if x minus a is a factor of p of x if the remainder p of a is equal to 0. So it's a factor if p of a is equal to 0. Okay. So, example 27. Remember, this is your p of x, this is your x minus a. So don't forget, a is -4 up there. All right, simplify the division using polynomial long division. All right, so you guys should be really good at this by now. So x to change to 3x squared would be a 3x. 3x times x, 3x squared. 3x times this 4, positive 12x. Put it in parentheses, subtract, change your signs. So this is really negative 3x, negative 3x squared, negative 12x. All right, so we're going to get negative 5x, carry down the minus 20. How does x change to negative 5x? By minusing 5. So this ends up being negative 5x minus 20. Put it in parentheses, subtract, change your signs. So this becomes a remainder of 0. Part B says write the result as an equivalent multiplication. So x plus 4, that's the divisor, times the quotient, which is 3x minus 5, that's your answer, there's your quotient, is going to be equal to your dividend, which is underneath that radical there, or not the radical, the division sign, sorry guys, plus 7x minus 20. Part C, evaluate P of A. Now don't forget, A is -4. So P of -4 means go back to the original, and it would be 3 times -4 squared plus 7 times -4 minus 20. So P of -4 is equal to 0. Okay, we know that. That's your remainder. Okay, so it should work out that way. So now it says, is x plus 4 a factor? And you're going to say yes. Why? Because the remainder theorem states, so remainder theorem tells you if P of A is equal to 0, which in this case it is, then you know that x plus 4, yes, x plus 4 is a factor. Okay? Example 28. Determine if each of the following are factors of the listed polynomial by using your recently found information. Okay, so remember, if P of A is equal to 0, then yes, we know it's a factor. Okay, that's the shortcut. All right, so ready? This is x minus A, so this is telling me A is positive 3. So P of 3, you go evaluate it. 3 squared minus 11 times 3 plus 24. P of 3 ends up being 0. Okay, you're just going to the calculator, you're storing it, doing something. So yes, x minus 3 is a factor. Okay, this one. A is -5. So P of -5. Just use your store key. So I do 2 times -5 squared plus 9 times -5 minus 2. I get a 3. So the answer is no. Why? You want 0. Next one. A is -1. So P of -1, you substitute in a -1 right here. And I end up with 0, so the answer is yes. Now remember, what are we answering yes to? It means that that's a factor. That this is a factor, okay? B, x plus 5 is not a factor. Why? Because it has to come out P of A is equal to 0. All right, D. D, your A is equal to positive 5. So P of 5, you substitute in 5 cubed minus 5 squared minus 19 times 5 minus 10. I get -5, so it is no. What does that mean? X minus 5 is not a factor of that. All right, last one here, example 29. For what values of k will x minus 4 be a factor? Okay, so remember, if it's x minus 4, then you know that x is equal to positive 4. Think roots. So now we're going to set it equal to 0 and solve. So 0 is equal to 4 squared plus 4 times k. Remember, this is your x, right? We're substituting in 4 for x. Minus 52. So now we're just solving for k. Okay, so I end up getting 16 plus 4k equals positive 52. How'd I do that? I just brought